All right, so for quiz 7, I'm not going to go through. There's the rubric had a bunch of important things about numbering and bonds work and bonds formed. For this point, I'm just going to kind of go through the mechanism. Here, just things to notice, right? You're definitely going to need a break, right? These bonds, right? The H's, these H's are probably going to come from the solvent. Remember, solvent's always in excess. And then this is catalytic, all right? So this is my nucleophile. These are that's my electrophile. Let's have these electrons go and add in. It doesn't matter which one we add into. Make sure you don't do SN2s. All right, so the oxygen's added in, balance my charge, if tetrahedral intermediate. You ask yourselves, do I have a good leaving group? I do. Some of you might say, well, wait a second. Oxygen is more electronegative than nitrogen. That should be the best leaving group. You're right, it is. But notice I told you the product. Also notice the bonds that need to be formed and broken, right? So with enough energy, you can make this happen. So we're gonna, we need to break this bond. So let's do the elimination with that. Electrons come down, eliminate, right? Keeping our charges balanced, of course. So we got 1/2 here. Now we have an amide, and the negative charge is there. So at this point, you're going to need to find some of that solvent, right? And do a deprotonation with that. And that kind of gets you back to square one, I would say. All right, some strange things have just happened. Don't worry about that. Deprotonation. Now we essentially have an amide, the ester up top, and we regenerate our nucleophile. So essentially this is going to do another addition up, tetrahedral intermediate, kick out the nitrogen. Essentially we get back to the same place as before. The nitrogen will deprotonate there, but more or less the same steps as before. So like I said, you can get you add in tetrahedral intermediate, the ester is still up top here. Do you have a good leaving group? You do. Kick out the nitrogen, eliminate that, and then that's going to need to deprotonate another solvent along the way to make sure that catalyst gets regenerated. So for number 2, again, things to recognize. You're in acidic conditions. You are going to take a ester and turn it into an amide. There's a nitrogen. This is how I just did a proline dimer. This is an amino acid. So the first step, acidic conditions, is always going to be protonation. So do the protonation. That makes that a more reactive electrophile. The ester, and then the nitrogen from another proline can add in, right? And again, it looks like it's a lot of stuff, but it's no different than a really simple amine. If you wanted to save yourself the pain and just draw it once, nice like, that's okay. Because it's really the same mechanism stuff we've been doing kind of over and over. All right, so now you got a nitrogen, and we can just say something else is there, don't worry about it. Be a little lazy. Do a proton transfer, right? Because we know we need to get the ester to go away, or this piece to go. We need to make that a better leaving group. Doesn't really matter what's down there. Make the ester a better leaving group. There's your nitrogen. Oh, no, the H is gone. My fault. H is gone. So just has that piece. Plus charges here. And then, this is all still here too. Don't worry. If you want to do that elimination, deprotonation all in one step, you could. That's just going like this. So that's a deprot, lose the H, elim, all in the same step because you're losing this H, regenerate the catalyst, and kicking this out and making ethanol as the byproduct.